Yeah. Good morning to all. This is Sivaraman, Director, Industry Institute Relations, EGS Pillay Group of Institutions, Nagapattinam, India. On behalf of EGS Pillay Group of Institutions, I welcome you all for the international webinar on research innovation, waste to health. For this, we have an eminent speaker from Multimedia University, Dr. Ervina Evzan, Associate Professor, and also Director, Research Program and Collaboration Center, Multimedia University. I would like to introduce her with a brief bio. She completed her PhD in Materials Engineering from University Sains, Malaysia. Her research is focused primarily to soldering, intermetallic and alloys, aluminum foam and nanostructured metal fabricated by powder metallurgy, mechanical alloying, nanomaterial and solar energy. Dr. Ervina's research interest also covers metal joining using friction welding, spot welding, and soldering techniques. She has more than 40 international publications, including chapter in books, book, and one Malaysian patent. Dr. Ervina has received awards from international and national agencies such as Telecom Malaysia, GCEU Award 2017, Crystal Award, and Green Award 2017 and 18 by Malacca State, Malaysia. In addition, she has received many other awards for her research, such as Special Award from Thailand Innovation Association, Romanian Forum Inventor, and World Invention Intellectual Property Associations. Dr. Ervina is currently involved as reviewer in journals, including Journal of Alloys and Compound, Powder Metallurgy, Material Science and Technology, Soldering and Mount Technology, and Solar Energy. She is also actively involved in consultancy for various government institutions and private companies, including conductor training courses for Dyson Southern Baghdad, CTRM Southern Baghdad, Infineon Southern Baghdad, and Ministry of Health, Malaysia. With this short note, I now invite Dr. Ervina Evzan to go for the presentation. Please.
Okay, thank you, Prof. Siva. Thank you to all of you to invite me on this webinar slot. Thank you to all of you. So I'm not really, as I informed to Prof. Siva just now, for this slot, because usually when I go for presentations or talk, we present on very technical discussion, very technical sessions. But for today, we are interested to give some talk or some slot on not really on technical stuff. This is how, as a researcher, how we, as a survival, as a researcher in university or in your country. Okay. So first of all, the title for our research, our talk is research innovations, ways to health. So what can we know about this? What actually ways to health? So before I go through with the presentation, let me introduce myself. I'm Dr. Ervina Evzan Muhammad Noor, currently Director for Research Program and Collaboration Center, Multimedia University. So this is my email, ervina.noor@mmu.edu.my. Okay. So what is a waste actually? So we can see here, they have a lot of waste in industrial, they have a lot of waste in world. So when you can see in the first picture, they have a lot of noodles packing. So after settle everything, after we eat, so they have a, most of us just put it on the dustbin, or maybe just leave it. So in this case, especially when now is COVID-19 pandemic, at the same time we have a lot of things we discuss, a lot of things we do at home because of lockdown, for example. So most of us very familiar with these noodles. So when we have a lot of waste, what kind of things we can do for this waste? As you, as a researcher, what kind of things you can do? So they have another thing is about paper. Even though nowadays we use paperless, most of us didn't. We just email without hard copy. So what kind of things we can do with this kind of waste? So day by day, they have a lot of papers, all newspapers, all papers in office. You also have a lot of papers in your office, in your room. What can we do with these kind of things? So at the end, the health become not in good conditions because of we have a lot of waste material. We have a lot of waste um, stuff in our life. Okay. We also have some other waste material, wasting we use. Nowadays, if I can say to you that day by day, they have a lot of phones, they have a lot of computer or PC or laptop, especially in pandemic. Most of parents struggle, most of children struggles with the use of technology. So can we imagine what kind of things, the waste of about the electronics, we call it e-waste. So these kind of things, what can we do with this material? Okay. We also have another one is we can see here is a can, Coca-Cola can, Lipton, for example. So all this is aluminium. So what kind of things we can do with this material? You as a researcher, maybe some of you already explore on this, but as a society, as a human, so what of the things we can do by decreasing or turn from the waste material to become something healthy, help to society and to your country or to world. Okay. So as I can inform to you, waste material is any substances which is discarded after primary use or not used. Or usually the waste material is usually referred to the material where it is unable to be reused, recycled, and transformed into usable material, and its existence had causes a series of problems: environment, air, and water pollution to our planet due to its increasing numbers today. So like in Facebook, in CNN, for example, people inform when issue with pandemic or COVID-19, suddenly everybody stopped to do work. So at the same time, the world become healthy. So is it because of we didn't use the waste material? So can you see here that the waste material usually refer the material which is unused. So we can think that most of the material we use, um, maybe we can innovate, become better material, better product. So type of waste we can see here. One is industrial waste. The second one is agriculture. If you can see industrial waste, for example, like maybe some of oil, maybe they have some of machine agriculture waste, for example, like stem or paddy stalks, for example. Hazardous waste is after we use the material, for example, like PPE, pandemic, when we use everything. So what kind of things? Oh, sorry, this one is for medical. So for hazardous is maybe some of the solution we use together with the some product, and then at the end, what kind of things we can protect this hazardous waste. And then we have a medical waste, for example, like the needles, the PPE clothes using by our doctor or our nurse, because currently they have a lot of PPE people use. Maybe you can go for this kind of research. So nowadays, the world has been looking for the maximum optimizations as possible in every field. So at the same time, during this, to get the idea, at the same time, maybe between the development or the process of the product or manufacturing in some way or others, it can does create a problem. So this information can create new idea for you to do research on the ways then to help. And then we also have a tend to develop or upgrade the innovations by considering all aspects. Usually as a engineering people, we can go for environment, safety, and the most important nowadays is about cost, because the cost is most of industrial, they're interested if the cost is very low cost, then people will buy the product. So actually, for example, like in Malaysia, um, last year suddenly we stopped to use any plastic. For example, like for spoon, for straw. Um, so this is another initiative by the government, but at the same time, we should the government should have some idea on replacement of this material. If, for example, like straw, what kind of other straw we can use to replace the plastic straw? How about the spoon and forks? Till now, they have still some researchers still struggle to have, for example, like straw. If I use a McDonald's straw, for example, maybe we'll take, if plastic, we take the durability or the strength of the straw is very good enough compared with a paper straw. Maybe we need to improve on that kind of straw. So this is some information or some innovations our researcher, you as a researcher, I'm as a researcher, we can doing some improvement on the product. But you also need to think about this also. Um, Even though we have a lot of waste material, but we need to know that some waste material is corrosive, some waste material is very reactive, and at the same time, some the material is very toxicity. So in this case, the consideration of the material we need to consider. So either if, for example, like the material is toxicity, what kind of things we can do, the positive impact, the positive innovations, we can get some idea from the positive view, and also for reactive material, unstable in nature. Okay, some of the waste material, actually, if I can go through most of the waste material study in India, actually. Maybe in India they have a lot of waste material, especially on agriculture. So the first one is rye husk, The second one is red mud. The third one is fly ash. Maybe from this material, I cite some paper from Prasad and Krishna, um, and Upadhyay and Kamal. So they inform about the elements inside of this material. For example, if we're interested to use high percentage of silica, maybe we can use that one. If you're interested to use high percentage of alumina, uh, and then calcium carbonate, for example, and then with the others material here, BaO, V2O5, TiO2. So you can get this material to replace to the current product if the current product need to have a high percentage of this material. So this is one, two, three. This is three material is always used in by most of people in India, especially for development new material. We also have uh, rice husk ash. So because this is agriculture waste, product residual from the rice milling process, the black to gray in the color. So in as I know in India they have a lot of paddy stocks. Okay, so maybe can use this kind of research. The advantages of this rice husk ash is better moisture resistant, improve the properties of metal composite, such as hardness and tensile. We also have a low density, but however, they also have a disadvantages. The number one is marginal effect, especially on mechanical properties. So this is some of information we can get from rice husk ash. So for example, like red mud. Red mud is maybe they have some country they have a red mud, uh, which is a major solid waste coming from their process of aluminium production. So when we have a aluminium production, so they have the waste material is like a red mud. So this material, this waste material, even though some company not interested on this, but maybe we can turn it from waste material become good or helped. eh? So by using this material, especially for polymer, a good compatibility with the polymer resin. So the marginal effect of these mechanical properties of composite is such as hardness, tensile strength. So this is some a good way for researcher to have to contribute to convert the waste material become a good material. So the next one is fly ash. I think fly ash is very famous material, famous waste material. So usually they produce the product is residual recovered by the gases of the mineral or cool combustions. So by using this fly ash, uh, some of the product become better product. After this, I will show you what is different, what is the good product, what kind of things we can produce by we add on or we use a fly ash in some our product materials. The good thing about this waste material is low density. The most important is inexpensive. Okay, it's good, it's cheap. Um, if in Malaysia we need to get a permission in from the government to get this product this waste material, even though they have no this is very cheap and no need to pay anything. So because of that, in Malaysia, I also explore in fly ash material, fly ash waste material. However, for fly ash, the disadvantages is low wettability and also chemical composition is a little bit um, there's some more on alumina and silica. Okay. So now I already informed you some of the waste material in research. If you're interested to do research, especially in mechanical, this is one of you can explore. So now it's more to creative in research because currently my position in university is more on collaboration and research program. I try to match between one researcher to another researcher. So to make sure these kind of things happen, we need to have a creative in research. So I always say to my researcher that creative in researcher should be done. Okay. Okay. The first one is when we want to become a creative, usually is environmental issue has become a topical subject is in recent year. Last time is with the heat in Malaysia, for example, but now it's more on pandemic. So everything is pandemic now. Issue in pandemic, COVID-19 is there. Numerous recycling resources such as wood chip, ashes, leaf, which are utilized waste material can be found in our life environment. Okay. So what can we do with this? Okay. Previously, everything is plastic. So if in your country they have a lot of woods, maybe we can use the cheap woods. Sorry, the wood. Some of the wood become a wood toothbrush, which is by using this, it's become the plastic from the plastics to the woods maybe become better. We also have bottle plastic. So one of the we have a lot of material from the plastic bottle. One of initiative is we need to carry out our bottle plastic. So on this one, when we carry out the bottle plastic, maybe this can solve some of our problem. But some of our parents also get the issue when you buy the plastic bottle is very expensive, and then we give to your son or daughter, and then they are missing. They forget to bring back to their home. But in this case, is when we have this product can be better. Then what should we do with the plastic bottle here? So maybe we need to think. We need to think as a researcher on this. Okay. I go through with you some of my innovation or on research from the waste to we can become the product. We can use the product. One of the product is one of the innovation is microstructure modification. Like I informed to you at the beginning, I use a fly ash. So we can see here this is for engine blocks. So previously the engine blocks, we can see the microstructure is in needle light. So when the needle light, sometimes the worst case happen when the temperature plus time at the same time at the end, the product easily to crack. So as a researcher, what should we do when these kind of things happen? So I can show you after I add some of fly ash, for example, here, the microstructure from needles, you can see here, become polygon. So, and then after sometimes at the end it's become better. So we can see that after we add on fly ash, from needle can change to a polygon or a round shape. So this is one of microstructure at the end of the product, easily to crack to become better. Okay. So if you can see here just now, this one, number one is 4%. So number two is BC is more to 4%, and then we have a 5%, and then at the end, so at the end the product, okay, at the end the product become a globular product. So we didn't see any needles here. So the probability, the structure, the product become better, especially on the tensile strength. So I also have another product, which is like I informed. One is just now is microstructure. We can change the microstructure. We can change the microstructure, become better. The second one is about glass. So the word glass is obtained from the Latin term, we call it glassium, which is referred to transparent material. Glass is usually defined as an amorphous material which is made by mixing the silica with other materials. The normal glass is usually made from three main raw materials such as silica, lime, and sodium carbonate. So if you silica is one of the main ingredient in glass. So from this kind of information, I can produce a lot of product by using this information. Okay, the first one is this one I got from recycling of waste glass in construction materials. So we can see here translucent concrete plate containing a waste glass. So we have a lot of glasses after the glass is break. So some of us we just throw it. But what can we do with this kind of glass? So they have they have researcher from China. They use this kind of glass to make a combination with some concrete element to make for the construction material. This is for construction material. So this is another ways we can turn it become better. Okay, so from that, from this glass, okay, waste glass, then at the end can make it the eco block. So this is in Hong Kong. Yeah, can make it a eco blocks. So this is another example we can use for we can think about the research we can do that. Some idea on the research we can do. Okay, so another product is glass product. Just now is about waste glass. Now is we produce or we develop the glass. So if you can see here, this project is MMU project, multimedia industry project. So for this one, actually it's from rambutan. So some of, because the skin of a rambutan, if you know the rambutan, the skin of rambutan, we can produce very nice glass, the layer of glass. So by using this rambutan, we add on together with other ingredient for glass, so we can produce glass. So the surface condition is okay, nice. They have no crack. We can see a little bit small crack, but the microstructure is good. Okay, so the good thing is transparent. The glass we should have a transparent, so no need to add on other element to make sure to bleach the color of the glass. So save our money, save our budget for this one. The second one is also glass, but a little bit the conditions still we can call it glass, but low grade glass. So in this case is we use palm oil tank of the leaf, sorry, the leaf of palm or palm oil leaf. So also we can produce a product from the waste because usually the leaf is after finish after the we get the fruits, and then uh, most of these people will cut the leaf and just let's say throw it or burn it. So by using this kind of glass, we can produce by using this kind of leaf, we can produce a good thing. We call it palm oil glass. Okay. Banana tree. So this is banana stem glass. So we can produce. It's very nice here. We can produce a banana. The banana glass is glassy and also transparent. Okay, we already done with the glass. Now, from the waste material also, we need to think that previously they have a product like a solder product. Now, most of the government interested to from lead solder to lead free solder. So if you can see, this is a solder, and then most of currently solder is the temperature is very high. So this is one of disadvantages. So the higher melting point at the end is can increase of peak reflow and required for assemble compared with the SMPB. Okay. So in this case, we can produce a solder which is lead-free solder. This is non-toxic. Using the leaching, for example, from waste electronic product. Okay, then we can at the end we can get the lead-free solder. So from lead-free solder, we can see here the from the microstructure. Even though the microstructure we can see here that is good, the intermetallic compound also good, even though the melting temperature for this kind of solder is about less than 230 degrees Celsius. So here is one of the microstructure. The top one is solder. This is intermetallic compound. The bottom one is copper. Okay, some of the product I add on gallium in the solder. I also add on zinc and indium in the solder. At the end, we can produce a lot of type of innovation. So we can see here when we add on different kind of material, the intermetallic compound is become thin. Okay. Okay, that one is some of information I already informed to you. This is just for sharing. From all these product, we have we already go through some award within from the beginning of the product, from the beginning of my career. So I won one of the Women Innovator Award in London. This is very recently. This is a recent year, which is last year on July. So I present some of my product. So we also have a. I also have a interview by Saudi televisions is about my product. So at that time is I won gold in my product in research. They have some research because I always go through on a green product. So we have one criteria or category you can join green innovation if you have a green product. So I joined this product and I won some of the award. Another one in Malaysia, we call it Telecom Crystal Award. So not only that one, so when you very active on research, especially in very critical area, you also got invitations for sometimes on TV, and then for last year, I was invited from 500 product in world. So I was shortlisted for 10 researcher. So I present in London. Just now you already informed to you about I won the global woman innovator. So this is one of event we can join. So this is another things you can explore because you are in research on health, ways to help. So I need to evaluate a researcher. This researcher is actually from your country. So this is not in India. This is in at that time is in Malaysia, I think. So I'm the judge for this innovation, international innovation. So they have some activities here, collaboration with other country, especially on because nowadays is pandemic issue. So when pandemic issue, they have a lot of waste product, waste material. So out there, all the researcher, you can join this kind of research. So at the end of my presentations, I think I can conclude that actually they have a lot of explore waste material research or green material, even though in terms of green research itself, or you can also explore on how to use the process of this green material. We can improve the product, we can improve the society, the things. And the second one is creative in research. uh, please bear that a negative can also be a positive, and then the ways can go to the health. Okay. So this is zero waste. Before I finish, this is my team. More than 10 my team, my researcher. So in my team, so I'm very proud to have them as my team. So thank you. I think that's all my presentation today. I hope that all of you enjoy these presentations, this talk, and perhaps they have some idea from you all to gain more innovations, more idea on innovation product or innovation research. I think that's all. Thank you, Dr. Prof. Siva.
Yeah. Thank you, madam.
Okay.
Thank you for your excellent presentation. The topic was extensively covered from fundamental to advanced level by citing very good examples. The information shared for glass product lead-free materials are very informative. And I'm happy to see the products invented by you. And I also wish on behalf of the participants, on behalf of our group of institutions, to get more awards in future. Thank you for exploring the research on waste materials. Now the session is open for questions. If the participants have any questions, they can use the chat mode, or if they want to ask question, they can use the hand raise to speak to you, or they can use the chat mode to put any question. So yeah, there is one question from Dr. Ramanujam. What are the research prospects for lead-free materials? Madam, your audio is not
Okay, sorry.
clear.
Okay.
Yeah.
Okay. Currently, actually in year 2010, most of the country, such as EU country, UK, and also US, most of this country already banned the lead solder. Okay. But compared with Malaysia, I'm not sure in India, but I think the same regions. But we in Malaysia and India, most of this country is still use some of plumbum or lead. We try to transform from plumbum to lead free. Okay. So what is the prospect actually is for example, like in my research, in Malaysia, I'm the first researcher in Malaysia who produced uh, solder, which is the temperature is less than 150. That means currently most of the solder is about 250 degrees Celsius. So when we use a temperature, it's low temperature but still stable. So most of the company interested to use, because why? The cost is you can cut a lot of cost, especially on the energy. Okay, so this is one. The second one is not only lead solder or lead free solder, you still have some parts, some research you can explore on add on new dopant. I say the dopant. Okay, so when you use dopant, you can improve some part of tensile, the strength or the hardness of the material, because previously, for example, your handphone is very heavy, and nowadays is your handphone is very you can use the handphone and just put in your pocket, and maybe not only one handphone, you have a 2 or 3 handphone with you. So they have a spec or prospect you can explore on the lead free. Thank you.
There are a lot of questions which is coming in, and due to time restrictions, we can answer for 2-3 more.
Okay.
And there is one question from Stanley Witt. What is the most effective way to control the plastic in all areas, such as packing and in everywhere? How can we replace it?
Okay. When when the government in Malaysia stop, they say all shop and all companies, all government parts cannot use plastic. Okay, so uh, then this one is start from policy in Malaysia, start from policy. But at the same time, as a researcher, we can together with the government, because for example, like me, we always very closely deal or collaborate with the government. If any issue related, for example, related with plastic, we can present to them that we can replace or transform, change from one plastic to paper bag, for example. So in this case, when the government comfortable and know that we can change, then the government can announce that the changes of the policy. But so my advice is you need to closely together with the government, present to them, or maybe start with your university first, and then you can implement. After that, maybe you can implement the outside. Okay. Thank you.
Yeah. So one more question from Dr. H. Geeta. How to discard the old mobiles?
How to discuss?
The old mobile.
All mobile. Okay. If you know that some parts in mobile actually is aluminium. We have aluminium. We also have tire. We also have. If I can get the one old mobile, they have a lot of things I can do actually. Like just now I informed about aluminium. We can use aluminium parts to produce the new things. When just change from the negative to positive. Okay, at the end, not only because we are engineering, so engineering we have a lot of technical knowledge. So we know that the ingredients or the element inside of that material, and then at the same time the performance of the things, the material. So I think to discard, um, give leave it to the government, but at the same time, as a researcher, from these kind of ways, we can use a lot of things. Okay, thank you.
So one more question from Dr. J. Madhusudanan. What is the recent method adopted to maintain zero waste?
Okay, the question is look like ask the government, ask the ministry. Okay, how to again? How to apa?
To maintain zero waste.
Zero waste. Okay. Okay, because we are not the first country. India, Malaysia also not the first country. I mean, we are a moderate country. So usually, for example, like UK, US, they drive most of the evolutions, for example. Okay. So at the same time, most of the policies such as a plumbum, lead-free plumbum, so all these policy actually is come from this kind of country. So we can use as a benchmark for this kind of country, and now is China also become better to use this kind of country. At the same time, actually, from waste, zero waste is start from home. Everything is start from home. As a researcher, you also can give awareness to people with waste product, waste material to become a good product. Okay, I think that's all.
Yeah. One question from Sri Abhidarshini Shekhar. In your presentation, you used LOI, that chemical element. What is that? She asked.
LOI is actually, this one is under X3, what you call it, SRF. So LOI is loss of ignitions, which is at the end. I think the presentation is at the end is nothing. Zero after the element is 1%, 2%. So we need to know that at the end, after we burn the product is after we burn the ash, so the percentage of loss. So this is we count as LOI.
Yeah, one question from Nivas: how to handle household e-waste?
Household events. Okay. For example, in Malaysia, we need to have a three. One is plastics. Maybe every house they have a different day. The pick up the rubbish. Yeah, the the wasting. They have a different schedule. One is for plastic, another one is wet waste, and the last one is like a leaf or cardboard or chair. So maybe we need to have this is one. And also some parts in Malaysia we didn't have dust outside dustbin. Yeah. So when we didn't have that one, so everybody need to if you want to throw something, especially in Malacca, if you want to throw something, we need to know that they have no dustbin, so we need to bring back to our house. So this is one, and maybe the awareness in your house. Uh, we need to know which part, what kind of material, what kind of product is you can reuse again, what kind of product we cannot reuse again. Because nowadays is most of the company also trade in, you can get money, and then you can get some money from you when you trade in some part of your product. Okay.
So this may be the last question. Dr. Manigandan Natarajan, is it possible to avoid plastic completely?
Is it compass?
Is it possible to avoid plastic completely?
It's depend on people. It's depend on government. It's depend on us as a researcher, because currently we didn't have. We still improve our plastic performance. Okay, uh, even though some of us use in some shopping complex, we use a plastic bag, or for example like in McDonald's or KFC, most of they didn't provide a plastic plate. They provide a paper plate. So even though a paper plate, but is we need to improve first our performance of the strength, durability, and also maybe the time used that plastic. Okay.
Yeah, this may be the last question. By name CA. What are the ways to pack food items instead of plastic bag? Do you have any suggestion or replacement?
Okay, as I still remember in year 2017 when I was in Taiwan. At that time, I met one researcher from India. Okay, so he produced banana plate. Okay, so this banana plate actually can use more than the banana plate can use more than 5 days. So I think these kind of things can explore by some researcher in India. I'm not sure is it already patented by these people, because this researcher, at that time I meet him, his age is I think less than 20 years old. So we invite him come to Taiwan and then give a talk in Taiwan about the packaging of the food. Okay.
So thank you very much for answering most of the questions very patiently, and we would like to appreciate you for your innovation. And I take this opportunity to thank the chairman, secretary, trust members, CEO, principals of Engineering College, Arts and Science College, Polytechnic College, directors, deans, HODs of various departments, senior professors, and young faculty members of EGS Pillay group of institutions for continuous support and encouragement. With this, I thank Dr. Ervina Ebzan for taking time to present today's talk. Thank you very much.
Welcome.
Thank you. Now I'm closing the webinar room. Yeah, thank you.